okay with that. I was trying to catch up.
So, but I want to go over just the last couple of types of bonds, and then I'll draw some instructions on the board, and we'll play with those. Everybody have a good weekend? Good weekend? I got a wild hair yesterday, apparently, and I have all the downspouts around my house are down because I had a dog that would chase squirrels up the downspouts and then pull the downspouts off the house so he could get the squirrel. And he's been gone for a couple of years now. The downspouts were still down, so therefore some wood on my house rotted. So I had that replaced. So yesterday, since it was a beautiful sunny day, I decided to go out and replace the downspout, which I did. Then I cleaned out the gutters. My boyfriend helped by moving his van so he could get to a space on the gutter. So, I'm fun. Should move that van and stay in it. So let's see. We talked about. Didn't we talk about amines as one of the functional groups, and that's an NH3. So, for instance, if you've got this, that would be considered an amine.
Is it NH2 also?
Yeah. Well, there's just one H off of that one because remember nitrogen can have 3 bonds. You can also see it written like this. What it would basically do is look like this. And then because you've got that, hydrogen needs 3 bonds, so you have nitrogen has 3 bonds, so you've got a hydrogen off there. So if it's got nitrogen in the chain anywhere, it's an amine. And it will have a fishy odor. That is a characteristic. So if you smell something that smells like fish, then it's an amine. There's also something that's called an amide.
So would that be fish?
So what makes it have a fishy odor?
It's that characteristic of an amine.
Like an oily, is it oily kind?
Kind of an oily, fishy, sicky, sweet almost smell. I mean, you'll know an amine when you smell it. You'll walk in and go, oh, that smells like fish. We used to work with amines for wet strength and dry strength in the pulp and paper industry, and you always knew when we were cooking amines. Okay? Then we can have an amide, which is going to have a carbon with a double bond, and then the amine or the nitrogen group added to it. So basically, you've got the carboxylic acid. The way they're made is you've got, remember, a carboxylic acid, the terminating carbon has a double bonded oxygen and an OH. If we replace the OH with nitrogen, then that makes an amide. I've posted some links on, by the way, I've posted some links under the resource tab to kind of help with all this. It lists all the different functional groups and how you name them and what they look like. Okay. So we've got amines, amides. Then we've got amino acids. Everybody knows what amino acids are, right? Building block. So you're going to have a carbon with some kind of functional group off of there. It doesn't really matter exactly what it is. But it's going to be attached to a carboxylic acid. And also have an amino acid. Now, the carbon chain, of course, could be longer, like in DNA and RNA. Carbon chain, the length doesn't really matter. But you're going to have a functional group off of one of the center carbons, a carboxylic acid terminating carbon, and then a nitrogen on the other end. So that's an amino acid. Okay, so far. And a lot of these things have their own unique names, so that's why I'm not really going over the names per se. All right. Yeah, why the hell not? Okay. So what do we have here? An amino acid. Okay. When we react amino acids, when we react two amino acids together, we get something that's called a peptide bond. Y'all should be familiar with those from DNA and RNA. All right? And when we get a peptide bond, what happens is we end up with basically tying the two amino acids together. We get a molecule that looks like this, two amino acids put together, and this is the peptide bond. If I ever get my book back, I'll give you guys some homework on this. CC's there. He's got my chemistry book. All right. So that's really going to be the functional groups and add-ons that we're worried about. So let's do some naming practice. Since I was easy on you over the weekend, I didn't give you any homework. What if I have, and sometimes you'll see the molecules just drawn like this. So each bin is a carbon. So when we're going to name this, we're going to name the longest chain first. So here we have 1, 2, 3, 4, 5 carbons. So what's that going to be?
Pentane.
5 carbons? Single bond? Pentane. All right. But we've got a functional group. This would be considered a functional group even though it is a carbon. What is one carbon? One carbon is methyl. So what carbon on the chain is that methyl group off of? Number 3. What y'all do this weekend?
Not chemistry.
Sorry, we're trying to get back in the game.
We need to study a little bit.
So it's going to be 3-methyl, you don't need to dash there, 3-methylpentane. Okay? And it'll probably help if I do it this way. Personally, I find the line structures confusing too. Better.
So that's like a shortcut way of writing that.
This is called the stick diagram. I mean, you may see them done this way. This is the formula or the structural diagram, and you may see it like this. C5H 3, 6, 7, 8, 9, 10, 11. Let me see it like that. Question. Okay. Nobody does it absolutely the same. You can have 15 different ways of drawing a stupid molecule. I think one of the things, even one of the links I even posted says something about to that effect that it just kind of depends. There is something called the IUPAC standard. However, there's disagreement on that standard too. So with me, give it a rough stab. Okay, so you name the longest carbon chain first. So here, if we did 1, 2, 3, 4, so we're not going to name that first. Here would be 1, 2, 3, 4. Here is 1, 2, 3, 4, 5. That's our longest chain. So that's the base. Then you talk about your methyl, your functional group. That goes first. And there is a hierarchy for naming these things. Maybe that'll help. If you've got multiple functional groups, Jordan, heard that?
Something similar, yes.
Isn't that on Angel? Yeah, I put it under this morning under links, resources, and then there's some links. Yeah, I forgot to do the other thing this weekend.
That's fine.
By the time I got in here on Thursday, I was so ready to forget the week. I was just supposed to be far. I did. It was terrible. All right. So if you've got organic molecules that have multiple functional groups, first you're going to look if there's a carboxylic acid. And that name would go first. Then you look at aldehydes, then ketones, then if there's an alcohol, then if there's an amine, then if there's an alkyne or alkene, then you name the alkane. All right. So in this case, same thing. All right. We're looking at it. We don't have any carboxylic acids. We know that because there's not a double bonded oxygen anywhere. Same thing with aldehyde and ketones, so we know we don't have that. We know we don't have an alcohol because there ain't no oxygen. We know we don't have an amine because there's no nitrogen. Alkane, alkene, or alkyne, alkene. We don't have any double or triple bonds. So then we just go straight for naming the alkane. We go with the longest chain, 1, 2, 3, 4, 5. So that's our base, pentane. And then add our functional group in front. Okay. So let's try another. I don't know what they've done with these boards.
They wash it with soap, some kind of chemical makes it sticky.
Which could be the eraser. It's just nasty. Okay.
Well, you can see the swirls where they've done
Yep. They're cutting back on everything. Okay, let's try this.
that carboxylic. I just guessed.
Carboxylic acid has a double bonded oxygen and an OH.
Okay.
So it's close, but it's just an alcohol. Okay. Okay. Now,
Wait,
how many?
carboxylic acid has a double bonded?
O and an OH.
Oh,
So now, we don't have carboxylic acid at all. No aldehydes, because no double bonds anywhere. No ketones, same reason. It is an alcohol because of the OH off one of the carbons. Okay. So when we name it, how many carbons do we have? 6. So what's that prefix? Hex. How do we? So we got hex. What else do we know?
Single bond.
All single bonded. It's an alcohol. No. Now, because it's not a straight chain, but a ring, we put in cyclo. So it's cyclohexanol.
say that again.
Cyclohexanol. All one word. Cyclohexanol.
No, I forgot all my stuff at home. Couldn't do that.
Because of.
You just completely forgot you were coming to chemistry today.
Apparently I forgot I was coming to statistics this morning too. Had a test, didn't bring my calculator, and any of that stuff.
Oops.
Yeah.
With Mr. Creech. No wonder he came over and kicked me this morning. I had my earphones in. I was rocking out to Peter Gabriel. He wanted to talk to me, so he kicked the bottom of my chair.
Oh.
What? Okay, so if it had just been a straight chain, it would have been hexanol. But since it's in a ring, it's cyclohexanol.
No.
The right paper at it.
Help me out, let me off a new piece of paper. That's nice of you.
Do it again.
All right. Well, I have something like this. Do I need to put the H's on there?
No,
As long as
no.
it's just H's.
Yeah.
Yeah, all the dashes that are on there are just H's. If it's anything else than a hydrogen, I'll put it on there.
Yeah, put them on there, put them.
Take up more time, I hear you.
Good. That's good.
Okay,
Is that 5?
well, count.
That's a,
Remember, we're gonna name the longest one.
So it's 6.
oh.
So there's 5 this way, 1, 2, 3, 4, 5. But there's 6 if we go 1, 2, 3, 4, 5, 6.
You can-
So we name the longest chain.
So you can turn and take corners.
Oh, yeah.
Yeah.
All right.
Sure.
So, what is 6?
Okay.
Hex.
Be hex. Hex.
There's no really
Ane.
specific functional group, so it's hexane. But we do have this hanging off of there, so what is that?
With what hanging off?
That is a.
Is it a group?
We'll consider it a functional group.
And there's 2 carbons. So you do.
That's a dose. I can't remember.
What's the 2 carbons? Ethyl.
Ethyl.
So this is going to be, where is that ethyl group? What carbon is that ethyl group off of?
The 3rd.
So it's 3 ethyl hexane.
Okay.
Not too bad. Not yet.
Not yet.
Go ahead and give it to lay it out.
Now I'm going to give you, let's see, I'll give you some names and see what we come up with. If I gave you methyl, cyclopentane. again, we start with our base. What do we know about our base?
5 carbons with single bond.
It's
Exactly.
a ring.
And it's a ring because of the cyclone. So let's do that. 1, 2, 3, 4, 5.
And
What the
it's,
hell is that? Hold on. I am so not an artist. Close enough. Let's do it this way. There, okay. Even though it's really not a circle. It's still a cyclone. Now what else do we know?
Methyl
methyl.
group off of it.
Off of somewhere, it doesn't really matter because it's not telling us where it is. So we can just stick it over here.
So if it doesn't tell you, it doesn't matter where you put it?
It's just gonna be somewhere off that ring because actually each carbon is the same.
Oh, because there's not like-
CH2, because there's not a
There's not-
differentiation.
And there's not like one, like,
And if there was a 3 or 4, where would you start?
That's the thing, that because it's a circle, it doesn't really matter.
Okay.
Now, if it said if it said dimethyl, then you'd have to put 2 of them on there, and then they'd have to differentiate.
what if you had a group off of it, like an aldehyde?
Then you'd have to differentiate which it came off
So
of.
you'd have to pick what would be one?
The name would tell you.
Okay.
So
Yes.
how come that carbon that the methyl's coming off of, how come that wouldn't be a double bond between there? Because you've only got 3
Because you've got other
bonds.
hydrogens that I just didn't throw in there.
Oh,
Okay,
So you
makes a
didn't put
difference.
the-
all right, okay. That makes sense.
When you do the stick model, they don't do the hydrogens on there,
And my question is,
Well,
which I don't know why.
that's kind of a, I mean, I should have thought about that anyways, because the rest of them would only have single bond, so.
Yeah.
if you had to count those, what would you start with number 1 in? That one?
One with the functional, well, the one with the functional group on
You
it.
start with the functional
Okay.
group.
So, all right, let's try this one. Here's the hierarchy.
Oh, yeah.
All right. Okay. What's our base?
5.
5. What do we know about it?
Double bond on the second.
Double bond on the second. So we've got 1, 2, 3, 4, 5. Double bonded on the second. Now what?
There's 2 ethyl groups off of, or is it, there's an ethyl?
One ethyl group off the second carbon.
I'm so smart.
One ethyl group off the second carbon. If there were,
He finally accepted the paper.
if there were 2, then it would be, if there were 2 ethyl groups, it'd be like 2, 4
Okay, so
diethyl.
you have to
Or just 2, 4.
specify
Yeah,
where.
you gotta tell it where it goes. All right, so then what does an ethyl group look like?
2 carbons.
CH2, CH3.
So, there's an ethyl group off of the carbon, and there's an ethyl group off of the other ethyl group?
No,
Because it looks like it's coming off of.
this carbon is attached to this carbon. And this is the ethyl group. 2 carbons is the ethyl group.
Oh.
Okay, so here.
I'm sorry.
It gets confusing, so,
I'm sorry.
all right?
I was still in my train of thought there's 2 ethyl groups.
That is the ethyl group. Oh, it's starting to make sense. Oh, ha, ha, ha. Just when you think it's safe to go into the water. Oh, next Tuesday, the 7th, we will not have class.
Or lab.
Lab.
Our lab starts at 12:30, doesn't it?
Yes.
No, we will not have a lab either. It's when they're doing the goal Rick Perkins luncheon thing. so we're gonna be there.
You're so special, you have to go to that.
I was nominated.
I know, you're special.
Oh, and last year, lost. Okay, this one's a little different. We know we've got an amine, which means we've got nitrogen in there somewhere. Now, when we're naming amines, think of the amine a lot of times as the central atom. Right? So we've got an amine and a nitrogen. What do I know about that? If there's two ethyls, this means they're on diethyl. This time there are two. But they're coming off of either side of the nitrogen. So it's got to be this. And what about the nitrogen?
It's in group 6 or 5.
How many bonds does it form? It's in group 5. So it's got to have 3. So we're going to have a hydrogen down here, and then there'll be that single pair of unshared electrons. Just like an oxygen has 2 pairs of unshared electrons, nitrogen's going to have 1. So that's
Wait. Oh, okay, 2 pairs. Oh.
nitrogen.
And just have.
Remember, it's in group 5, so it's 1, 2, 3, 4, 5. So it can only form 3 bonds.
There she goes.
Okay? But it's, the amine tells you there's a nitrogen. Diethyl tells you what's on either side. Now you could have methylethylamine. All right? So if we had something like methyl, ethylamine, that means nitrogen's in the middle. On one, I've got a methyl group. On the other side, I've got the ethyl group. Still going to have this.
So you automatically know with all of these, I know this is probably something stupid, but you know there's hydrogen. If there's a spot open,
Yeah.
there's a hydrogen.
Unless it says there's something else there,
It's a hydrogen.
then it's a hydrogen. Could also call it ethylmethylamine.
What is that? In the natural world.
I believe it's called MEA. You'll see it sometimes like in shampoos. A lot of the amines, even though they smell like fish, a lot of the amines are used in shampoos.
Because they're oily.
All right.
What are you working, or is that on Angel?
No, I haven't put these on Angel.
Oh.
What I'll probably do, tomorrow in lab, we're going to do an ester lab. We're going to do the ester lab. And then what I'll probably do then for the week that I'm not going to be, that I'll be next Tuesday, I'll put some kind of worksheet like this on there to kind of sum up everything that we're going to cover in Chapter 8. We need to get into Chapter 9. And then we'll have that will be your lab kind of thing, and then we'll have our first test. Dun, dun, dun.
Or the next week.
Next week. Because remember, it's a take home.
Oh, you'll give it to us like next Tuesday.
I'll
when I'm
post it
not in
next
class.
Tuesday, yeah, while we're in class, when I'm not in class. While I'm being wined and dined at the country club. Lottie. Da. Okay, let's try this. So what kind of molecule is this?
Ester. That's the functional name, right? Ester.
Is it ester or ether?
Ether, yeah.
Does an ester have double bonded
Double
O?
bonded up, yeah.
So this is an ether.
Ethers have single bonded oxygen in the middle.
And esters have a double bonded oxygen off the middle.
Off of, not in the middle.
Ethers will have it in the chain. Okay, so now, we know it's an ether. And we do it kind of like we do the amines. So I've got two groups coming off the oxygen. So what do you think? What's the longest chain?
The 500.
5. So what is that? Pentane. So that's going to be pent. It's pentane, but we call it pent for this case. When we're naming esters. It's the Easter bunny. Ether bunny. We're naming ethers. Pent. Put oxy where the oxygen is, and then what's on the other side?
3 plus 4.
Propane. Pentoxy
So that's where you
propane.
put the
Hmm?
You put like the and.
Pentoxy propane.
So you wouldn't use the longest carbon chain as the backbone, or as like the base?
Apparently not, according to this. I have a note. You could also call it propoxy pentane. This is where I say that they never name them, nobody ever names them the same way. Okay. Technically, you should use the longest chain. But either one is going to be okay because ultimately it's still
the same.
telling you what it is. Either one is fine. The bottom one is the with the little pinky sticking out, the most proper. But either one is okay.
Like the bottom one is the what?
The more proper one, technically.
I saw that I would put the 3 first.
Because you do technically name the chain
Off of the longest.
of the longest. And that should be your base. But either one is okay. Just to make it a little more confusing. And make your heads feel like they want to explode.
So this is all in chapter 8?
Yeah, kind of, sort of. I'm going a little more in depth than in chapter 8.
I like it.
We're not going to get into actual reaction. Well, towards the end of class, I'm going to get into the reaction that we did on Tuesday. Okay. Chemistry reaction, the actual chemistry of it. All right. Try this one. So what kind of molecule is this? Carboxylic acid.
Do you have to put an ene because it has a double bond with oxygen? Like if
No.
you
It's the double bond only applies if it's in the carbon,
in the
in the carbon chain. Okay. When we name carboxylic acids, and a lot of them have their own specific name, but if it doesn't, we can also add an oic on the end of it. Oic acid. Oic acid. So, what's our chain? 4. So what's 4? Bute. This is actually wrong on here. She's wrong. All right, so we've got bute. What do we know about the carbon chain?
Single bonds.
Single bond, so A. It's a carboxylic, so it's going to be oic acid. Butanoic acid. What else is on there?
A bromine on the second carbon.
On the second carbon, so it's going to be 2-bromo. Butanoic acid.
Why do you have to say bromo?
You use bromo, chloro, io. You just use the beginning syllable of the halogen that's attached to it.
Okay.
It's bromine, but 2-bromo. That's enough to tell you what it is. 2-bromo butanoic acid. So you're starting to see the patterns to these, kind of, sort of?
They all have their special rules.
They all have the special rules. None of the rules are the same for anything else.
Mhm.
All right. What molecule is this? Off essential, what'd you say? Acetone? It's a ketone.
Oh,
Double bonded oxygen off a central
central.
carbon. There. Now, how many carbons?
4.
Bute. What about the bonds? And what's the ending for ketone? Butanone. Butanone. It's kind of like little puzzles. So now you're going to go home and look at all your stuff in cabinets and read all this, what this nasty stuff is, right?
Oh, yeah.
But we're not going to know what the names are because they probably made up their own.
You will. Okay. How many carbons? Pro. What's special about the chain?
Alcohol to alcohol.
So it's
Anol.
pro, anol,
2chloro.
perfect.
You got it perfect.
Oh, perfect.
Maybe you should bring your books to class.
Ow! Of course, it would help if he bought a book.
Oh my gosh, you don't have a book?
I don't think he ever bought one last quarter, did you?
You didn't have a leg? No, he didn't.
How do you not have a book for chemistry?
And if we want to get really fancy, we could stick a 1 in here to tell us where the OH is. But since it's on a ending carbon, it's not necessary.
Where would you put the 1 in? Would you put it before the propyl?
Yeah. If ultimately proper, but it doesn't have to be there. The only time it would have to be there is if the OH was off a different carbon. Because with alcohols, it doesn't have to be on a terminating carbon. It can be anywhere.
So then you would have to put
Like if it were here. Let's do that. Let's leave that there. And we just had that. And that would be 2-chloro, 2-propanol.
And the other one was 1 propanol because we were counting backwards because
From the primary functional group, which is the alcohol.
So where do you count from this side? Just any one?
Doesn't matter because it's the same carbon from either way.
2 chloro, 2 propanol.
But if you had another carbon out here on this end,
Then
Here.
like that, so then
it would be 3.
3.
No, it would be 2.
No.
Sorry, you start from the shortest side. It'd still be 2. be 2-chloro,
Two.
2
Pro.
butanol.
Oh, yeah.
Because you got 4 carbons.
You changed it, yeah.
Mm.
It's a count. How many carbons?
Hint, hentai. Y. Y. To,
Pentine. And you could do
But
2
two-
pentine,
yeah.
because that's where the triple bond is from.
To make it interesting.
You want a functional group? Hush.
So are the other ones only in hydrogen as well? And the ones on the bottom are hydrogen?
Yeah.
Okay.
How many carbons? So what's that? What about them?
Single.
So propane, there's no other functional group on there that changes the name, like an aldehyde or any of that kind of stuff.
So do you start with?
Go in alphabetical order, kind of, sort of, kind of, sort of. So where's my bromine,
First.
right? So it's going to be 1 bromo,
2 chloro.
2, no, sorry,
One.
1, 2
Oh, yeah.
chloro, propane.
Cool.
So when they put.
And actually, it's dichloro, sorry. Forgot. Dichloro.
Not going to.
So when they put like all these chemicals and stuff, when they really put them on the back of the bottle, do they put like one something, blah, blah, blah?
They do not, because that would scare the hell out of the general public.
If they wrote that,
On your shampoo bottle, you're going to automatically assume that it's something deadly and dangerous.
1 bromo, 1, 2 dichloro.
they'd probably just put propane or something.
Most of these things, if they're in the industry and being used in the industry,
They have
there'll
a
be a
name.
common name.
Mhm.
They'll rename
There'll be a, well, they don't call it that, they call it a common name.
it.
Like, for instance, water,
Mhm.
they don't put dihydrogen oxide on there. The minute they put dihydrogen oxide on there, somebody's going to go, oh my God, there's a deadly chemical in here.
I would just laugh if I saw 1 bromo. But I get what you're saying.
Well, it's like there was a while there, I think it was Estee Lauder or Clinique, I remember, this was years ago. I walked into the mall here and walked into Parisians, and they had this whole big campaign running about chemical-free. Everything was chemical-free makeup. I'm like, does it have water in it? Yeah. Well, that's a chemical.
I bet they loved you.
Yeah.
Of course, this is the little girl at the clinic or the whatever was counter going, what? But it's chemical free. Whatever.
My dad would say.
That ad didn't last very long. Campaign didn't last very long.
The term free doesn't exist anymore.
What?
The term free doesn't exist anymore.
Well, you can't have chemical free. It just don't happen.
I wonder what they were talking about.
That means bad chemicals.
Why don't they say that?
Yeah.
Is this gonna be a joke?
That's the bad chemical. Let's see. Let's give you something interesting. Ooh, that looks pretty.
So how do you choose which one to go off if they both have
The
six?
longest one is your
Oh,
base.
the longest.
Mhm.
I'm just
It's kind of like a final wood or whatever.
nine. Nine? What's nine again?
No.
No.
So 9,
Nana.
which would be non, but we don't have any double bonds in there, so we know it's going to be nonane.
So then do you have to put those as functional groups at the top, or since it's a part of the base chain, do you have to put that top part? You know, like.
Well, now remember,
No, you
look at
do
this.
the bottom.
Okay, here's your base chain. 1, 2, 3.
Yeah, so you wouldn't put that top, you did the bottom part.
There's our base chain. What's attached to it?
And methyl and then ethyl?
Okay, so which would come first?
Methane.
Ethyl.
Ethyl.
Alphabetically. Ethyl comes before methyl. So where's my ethyl group coming off of? What carbon? So it's 4 ethyl,
Two methyl.
2 methyl.
What is no, like, would nonane be something we would know?
It's an anonymous. It has no name. No name.
Methane.
No name. Ooh, that looks like fun. It's our longest chain.
1, 2, 3, 4, 5, 6, 7. Well, would you go 1, 2, 3, 4, 5, 6, 7 on the bottom? Like go to the bottom and make that a chain, or to the top and make that a chain?
Well, now these aren't connected.
See, I would
So it's gonna be
start
this.
right there and then take a right.
Oh, so those two carbons on the bottom aren't bonded together?
No, they're not.
Oh, because they have hydrogens on them in the bottom.
Right. Okay, so what's our base chain?
6.
Which is? So this is going to be hexane. What else?
So we have 2 functional groups off of it?
We actually have 3.
Oh, but
And
those
they're
2 on
all-
top aren't. They're all methyl.
So now, this is going to be, anything that'll help when you're counting your chains. So
Would it be the
1, 2, 3, 4, 5, 6.
Would it be,
Do you have to put
Try methyl.
methyl is what it says. Trimethyl.
Trimethyl, and where are my methyl groups?
They're off of
Not
off
one.
of 2, 3.
2,
2, 3, 3, trimethyl.
So when you have to put the trimethyl or the dimethyl.
It is preferable that you do it. You don't have to, because the fact that it says 233
Yeah.
means there's 3 there. Last one, and then we're going to get into what we did in the lab. All right, so we've got
So there's a carbon off of a carbon, and then there's a carboxylic acid off of a carbon. That's
Where's our chain? Where's our longest chain?
1, 2, 3, 4, 5. 6, 6.
Do 6. And do all. This would be our carbon chain. Okay. So what's our prefix for a chain, carbon chain? 6. X. So carboxylic acid, how do we do the carboxylic acids? Oic. So hexanoic acid. And what's on our hexanoic acid? Which carbon is it coming from? Count again.
1, 2, 3, 4.
From the functional group.
1, 2, 3.
3 methyl hexanoic acid.
So if there's a functional group, you count from it, but if there's not, you count from the shortest.
Right.
Okay.
If there's something in the chain, like something interrupting the chain, then you use the shortest. Yes, or alphabetically, whichever one comes first, actually. Like when we did when we had this,
You start from.
well, this would be
Right side.
ethyl propyl.
Oh, so you do ethyl propane.
Okay. All right. I'll post these copies I've been working from with the answers. I'll post that on Angel so you can take a look at them and practice with them.
I need it.
We've pretty much gotten everyone wrong today.
It's just, you're just remembering. Okay, now, what we did in lab. You've got that. How would you name that?
Well, it's an alcohol, right? Got 3 carbons, singly bonded.
So how about 1, 2, 3 propanol?
1, 2, 3 propanol.
However, this is common name is glycerol.
So if we saw glycerol on something, it would be this.
Okay. When they make oils, they take glycerol and react it with what you guys are used to. What is that?
Got a double bonded oxygen would that be considered or like a terminal carbon?
Ketone? Is it a ketone?
Ketones in the middle.
Ketones in the middle.
Aldehyde?
Carboxylic acid. It's a double bonded.
Oh.
Okay. It's a carboxylic acid, and we group these into a common name called fatty acids. When they talk about fatty acids, if all the carbons are singly bonded, then that's called saturated.
Because you add hydrogen to saturate.
Well, no, you've got all the carbon bonds there, and they're all available to react. Whereas if you have a double or a triple bonded, those are called unsaturated.
And those are the better ones, right?
The harder to find, too.
What makes it unsaturated?
Unsaturated would be if you've got double or triple bonds within the carbon chain, the main carbon chain. Okay. So what we did to make the oil, or what they did to make the vegetable oil that we used, is react these two. All right?
How do you react to the two of them?
You're going to heat them up, mix them together, and heat them up usually. There are things that will want to go together. There are things that won't want to go together. These guys like to go together. And you form something that looks like this. So you're going to have carbon. Can you all see that?
It's messing with my eyes.
Yes.
I'm sorry, is that bothering you?
Hurt my eyeball.
Sorry. Let me get a non-neon color. And we're going to have an H, 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 H. Everybody else, this is R1, R2, R3.
Now,
This- This is called a triglyceride. Okay, that's what they're talking about when they talk about triglycerides. They're checking your blood when you're doing your cholesterol checking, and your triglycerides are okay. Like with me, my cholesterol is high, but my good is higher than my bad, and that kind of thing. I mean, that's what they're looking at, is structures like this. So that's oil. That's what your corn oil looks like. That's what your vegetable oil looks like. That's what your canola oil looks like. And they all have that base structure of a triglyceride. Okay. And then what we did was take that and we reacted it with, what did we put into it? Remember what we took?
Aldehyde? Oh wait, what did we put in?
Into the oil.
Was that alcoholic?
The,
Oh, the yeast?
no, the sodium hydroxide, was it?
We put sodium hydroxide, but what was it in? You remember what we mixed it in? The heat, the methanol.
Oh.
So we took this triglyceride, and we added 3CH3OH. You didn't realize that's what we were adding, but that's what we were adding. Okay? We were adding the alcohol. So we were taking a triglyceride and an alcohol, and we used the sodium was a catalyst for the
So
reaction.
that 3CH3-OH, that's not the glycerol.
No, this is the
That's
triglyceride.
the methanol, gotcha.
Okay, and we're adding the methanol. We put the sodium hydroxide in there as a catalyst. And what we did was produce 3 moles. Oh no, she's using moles. Of biodiesel, which looks like this.
I hate moles.
That's what the biodiesel looks like. There we go. Basically what we did was we've got the ester linkage, that's what this is called. These things right here, these are called ester linkages. Okay, and we form the biodiesel, which basically we broke these things down. And, believe it or not, we form a glycerol, which is this. We form that again.
So fatty acid plus.
We took the oil, which was a reaction of glycerol and fatty acid. That was reacted together, we got that. We took that, reacted it with caustic methanol to produce the biodiesel and the glycerol.
And that's what separates out as a glycerol on the top. Is that what you said?
Biodiesel's on top, glycerol's on the bottom. And you'll see when we go in tomorrow that it has split.
So do you need it?
What we'll do tomorrow, there's usually a wash phase that you've got to go to, so I'll get that going tomorrow while we're doing also the ester lab. And at the ester lab, we're going to take alcohols, you react them with alcohols, react them with acids, and that makes esters. And esters all have a scent to them, like banana oil or wintergreen and that kind of stuff. And we'll do that tomorrow. And I'll put it on tonight, the lab on tonight. Okay? And I guess that's it. This is as in-depth and into organic we're going to get, okay? The naming and some of the reactions. But if you take organic chemistry with me next in the fall, which apparently I'll be teaching in the fall, this is probably where we'll start. Pick that up.
So there's a lot more.
Oh, God, yeah.
Got it.